So before going into the ECG heart rate calculation, we should know what is the paper, like ECG paper, what is the calibrations in it. So it becomes easier for us to calculate the heart rate. So ECG has two axes. Any graph, they will have two axes. Along the x-axis, the speed is depicted. What is the normal speed that is preferred to record an ECG machine? It is 25 millimeter per second. What is the amplitude along the y-axis? In all the ECG machine, the starting wave, they will record something like this. You just go and notice it, there will be a calibration for this. What does this amplitude calibration says? It says that 10 mm is equal to 1 millivolt. For every millivolt, 10 mm will be deflected in the paper. And usually in an ECG paper, there are larger boxes and small boxes also. These larger boxes are made up of 5 small boxes. They are made up of 5 small boxes on both sides. So this is the smallest box which will have 1 mm cross 1 mm in the entire ECG machine. And we can calculate using the larger boxes also and the smaller boxes also. This 1 millivolt is recorded by 10 mm, that is 2 larger boxes will be recorded. So now calculated 1 mm. For a single mm, what will be the voltage potential? It is the 0.1 millivolt. It is the 0.1 millivolt. And if the paper speed is 25, tell me for 1 mm how much will be the time duration. So 1 mm will be 1 by 25, that is equal to 0.04 seconds. So this is the calibration for a single smallest box in an ECG. So it is 1 cross 1. What is along the x-axis? Along the x-axis we have the speed, which is 0.04 second. Along the y-axis we have the amplitude. What is the amplitude? It is 0.1 millivolt. So this values we should know. Now coming to some of the normal values, you just have to remember these normal values. The P wave completes around 3 squares. What is the seconds? What is the duration for 1 square? It is 0.04. So multiply it by 3. So it is normal duration is 0.12 seconds. The PR interval. So it includes P wave and PR segment. P wave plus PR segment. I told you interval means they will constitute the wave as well as the segment. So what is its normal value? It's around 4 squares, which is 0.16 seconds. If it is more than, I'll tell you in the hard blocks also, if it goes more than 5 squares, more than 5 squares is equal to 0.20 seconds, then it is called PR interval prolongation. We call PR interval prolongation one as and one only it crosses the 5 boxes or one big box we can say. Then coming to the QRS complex, it is also 3 squares, which is 0.12 seconds. Then the XT segment is also 4 squares, which is 0.16 seconds. So these are some of the normal values we have to remember. Now coming to the heart rate calculation. How will you calculate the heart rate? So for right now, we know along the x-axis what is the speed of the paper and what is heart rate. Heart rate means for every 1 minute, like how many heart is beating or one cardiac cycle is completed. This heart rate means like it is the completion of one cardiac cycle. So in an ECG, if I pick up two similar points, for example, top of the P wave and another top of the next P wave, that will give me a one complete cardiac cycle or one heartbeat. We prefer to take the RR intervals. Why? The reason is pretty simple. RR is very prominent, so we can take it easily. So the distance between one RR interval is nothing but one heartbeat. So now we know the paper speed. Let's do paper speed. What is this paper speed? Is 25 millimeter per second. Heart rate is calculated for 1 minute. So how much paper would have traveled in 1 minute? That is 25 into 60, which becomes 1500 millimeter per minute. For 1 minute, the paper has travelled 1500 mm. In that, what is the RR interval? RR interval is for one heartbeat. So now what we have to calculate, how many times this RR interval has passed through the 1500 mm, because that is 1 minute. So if I know the number of time taken between two RR interval, then that will give me indirectly the heart rate 1 beats duration. So now we can convert it to for a 1 minute. How to do it? So now we will calculate the number of small boxes between RR interval. That will give us one heartbeat. So in 1 minute, 1500 mm is travelled. So if I divide this 1500 by number of small boxes between RR interval, that is going to give me the heart rate. So it is pretty simple. Now we can do it for the larger boxes also. We can do it for the larger boxes. How many large boxes would have traveled in 1 minute? 1500 is for the small boxes, and 5 small boxes make one large box. So instead of 1500 small boxes, I can write it down 1500 divided by 5, that is 300. So this 300 we'll take it down here, 300. But now we have to take for the RR interval large boxes. Number of large boxes between RR interval. So that is going to give me the heart rate calculation. Either you can do it with this or this. Preferably, if it is asked in a very like 72 beats, 78 beats, something like that is given in the option, go for a smaller boxes. Clinically, this larger boxes is a better version.